Now in part C, the investor is going to invest a sum equal to the present value of the liability. So that means he's going to take an amount, the $100,000, and then he's going to discount it by 7.247 years, and he's going to take that amount and invest it in this loan stock. So when he invests inside this loan stock, he's going to receive all the coupons and the redemption value and everything that comes along with it. And then we want to find whether he can achieve immunization given that the convexity is equal to 60.53. So first of all, remind ourselves what are the conditions to achieve convexity. So first of all, the present value of the assets. So assets refer to whatever creates positive cash flow for us. It's going to equal to the present value of the liability. So this is the outflow, so the $100,000 that the investor has to pay out in time 7.247. And the first derivative has to be equal, and the second derivative of asset has to be larger than the second derivative of the liability. So essentially, if we satisfy all these three conditions, the present value is going to look something like this. So it's going to reach a minimum, and then this minimum is going to touch at this very point here at 0, and then it's never going to go below the y-axis, so it's never going to be negative. So that's the whole idea of immunization. So let's check whether these three conditions can be met. So the first condition, that the present value must be equal, this has to be true because this is by definition of what's going on. The present value of the asset is going to be whatever he invests inside, and he's going to invest the amount that is equal to the present value of the liability. So by definition, what the investor is doing is going to satisfy this first condition. So for the second condition, the first derivative has to be equal. So when we compare the first derivative, we can also it's equivalent to comparing the convexity or the duration, because the duration is really just the first derivative divided by the present value. So if this is true, so if the first condition is met, in order to find whether the second condition is met, we can just compare the duration or the volatility. And as we found before, the volatility is equal to 6.71 in both cases. So the second condition is also true. And note that it doesn't really matter how much we invest into the loan stock, because this f is going to cancel out with in the numerator and the denominator. So whatever we invest inside the loan stock will still get a duration of a volatility of 6.71. So this has to be satisfied. Now for the third condition, this should be a larger sign, not equal. So for this third condition, the second derivative has to be larger than this second derivative. This is essentially the same as comparing the convexity, because if the first condition is met, then the convexity is really just, if you compare the convexity, it's the same as comparing the double derivative, because the convexity is just a double derivative divided by the present value. So as we found in the previous question, we found that this is going to be, well, not exactly this number, but the convexity of the liabilities is equal to 51.2397, and the convexity of the assets is going to equal to 60.53. So obviously you can see that this is larger than this, right? So that's why the third condition is also satisfied. And so as you can see, the three conditions are satisfied, and immunization is going to be achieved.